So if we're going to deal with a Poisson distribution, this question does say it's a Poisson distribution, the three things we're always interested in seeing is random, and we have that, independently, and uniform average rate. And we've got two of those. So the one thing that we're missing in this particular case is the independently. So it is, if you put independently, you will get 1 mark for this, but you've got to actually justify or explain in your own words what independently actually means. So you can see that I've put down a couple of things at the bottom. Right, I've used the word independently and I've explained it as best I can so that the occurrence of one doesn't cause others to occur. They don't clump together, if you like, and you can put language like that in as long as it's clear. So the two things you're looking for here in this particular case, and it's always interesting to look for how many marks there are in a question, because that will tell you how much information you need to give. So if it's a 2 marker, you really need 2 points. This is a typical start question, so anytime you see a Poisson type question, then you need to think about the 3 conditions that hold. That is random, independent, and uniform average rate. So just work out which one's missing and explain that. Now we'll get on with the question itself. So what I had in my previous part was the uniform rate was 2.5 mil. So 2.5 mil or 2.5, sorry, bacteria, my apologies, in a 10 mil of solution. Okay, so 2.5 bacteria in 10 mil of solution. So that gives me that what I've got here is a Poisson distribution. It's always a good idea. It doesn't really matter whether you put P or Poisson there. A Poisson distribution, we don't tend to use P because P is probability for mathematicians. And put the parameter in this particular case with a Poisson distribution. Typically the parameter is lambda, and what's interesting about Poisson distributions is that the mean and the variance are the same. So the mean would be at 2.5, and the other thing to remember is that Poisson is a discrete distribution. It only takes whole numbers of, so you'll either have 1 bacteria or 2 bacteria or 3 or 4 or 5. Technically you can't have 2.5, but because it's an average rate, you can get decimals. Don't get hung up on that sort of thing. We want to find the probability that in a 10 mil, so we're dealing with a Poisson of 2.5, okay, that I've got at least 5. So what I'm actually asking for is I have got that my variable is distributed with a Poisson distribution with parameter 2.5, and what I'm asked to find is the probability that x is greater than or equal to 5. Now, Poisson distribution means it could be 5, 6, 7, 8, 9, 10, etc., etc. So I want the probability that x equals 5 plus the probability x equals 6 plus the probability x equals 7, etc., etc., etc. Now, because that keeps on going and it's too much like hard work, what we tend to do is we know that the restrictions for probability are 0 and 1. Something's definitely going to occur if it's 1, and it's definitely not going to occur if it's 0. So therefore, the probability that I want, x is greater than or equal to 5, is exactly the same as 1 minus the probability that x is less than or equal to 4. And this is where it's important that you consider it's discrete. So I've got to now evaluate this probability. The other thing with my normal, or not normal, with my Poisson distribution is to remember that my probability that x takes a particular value is always given by e to the minus lambda, lambda to the r, divided by r factorial. So if I want to do 1 minus the probability x is less than or equal to 4, clearly I've got to work out that particular probability. And I could, if I wanted to do the probability that e is 0, or probability x equals 0, plus the probability x equals 1, plus dirt, all the way up to the probability x equals 4. And that's actually quite a bit of work. So we didn't tend to do that. So the two ways of doing it are using my trusty FX991 ClassWiz, the nice little calculator, or I can use tables. Now, unfortunately, when this question was chosen, I have a sneaking suspicion that I actually chose this question. We didn't have access to the WGJEC papers and the formula booklets and the statistical tables, and you can actually see that 2.5 is missing. So we can't actually evaluate it from tables. I'll show you how to calculate it from those tables by a slightly different way. But clearly on the ClassWiz, you're looking at menu 7, go onto the second screen using the silver down arrow, choose option 3, and we want a Poisson CD, a cumulative distribution. So we want Poisson CD. French mathematician, incidentally, Poisson doesn't mean fish. And we're going to choose 2 variable. And this, of course, because the calculator works in English, will be in English. And my x value is 4. My parameter is 2.5. So I press 4 equals 2.5 equals, and my calculator will return to me 0.8911780205. So the calculator, the value I want, the probability that x is greater than or equal to 5, is 1 minus that 0.8911780205, which gives me a nice little probability of 0.10882197995. Now some boards would call that overstipulated, so I would choose in this particular case to call that 0.1088. We could get much the same sort of value using the tables. If I look at the midpoint of those two, I will get a figure very, very close to 0.8911. So my probability that x is less than or equal to 4, because the tables give us the left-hand bit. And so what this is actually giving me is the cumulative probabilities of 0, 1, 2, 3, 4. And so therefore this would be 0.8774 plus 0.9041, all divided by 2, and that gives us something very close, but we're extrapolating there, or interpolating actually to be more precise, between 2 values, and it's not quite accurate. So a couple of ways of doing it. I could calculate each of them separately, or I can use my calculator. All right. Calculators tend to be a little bit too over accurate, so as you can see, the tables are given to 4 decimal places. 4 decimal places a reasonable degree of accuracy with statistical questions. Now, important thing to notice that is now I've only got 3.7 mil of fluid. So, and I want the probability of exactly 2. Bacteria. So what I'm looking for here is the probability that x equals 2. And because it's worth 3 marks, this comes from a day which precedes the trusty calculators. I'll show you both ways of doing it. In fact, I'll show you several ways of doing it. Clearly, the first thing I need to do is to work out my parameter. What I had was 2.5 bacteria in 10 mil. If I reduce that to 3.7, my parameter now is 2.5, the number of bacteria I'd expect to find in 10 mil, times 3.7 divided by 10, because that's the fraction I've got. Now that turns out to be 0.925. So therefore my new parameter is that x is a Poisson distribution with parameter 0.925, and there is no way you'll find that in a book of tables. So the 2 ways you've got of doing this, and because it's worth 3 marks it would be worth doing, the probability that x equals 2 is e to the minus 0.925 multiplied by 0.925 squared over 2 factorial. Now we all know that 2 factorial is just 2 because it's 2 times 1, but it's worth doing that. Okay, just to show that you do know exactly what you're playing with. Now, so what I get here using my calculation, and this is where I would use a calculator in normal calculator mode, I've got 0.1696410,977. So the probability that x equals 2 is 0.696 to 4 decimal places. And I suppose if you want to be precise, you ought to put in 4dp there, but it's sufficient just to say that's what I've got. The other way of doing it would be to use my trusty calculator again, 991, but this time, so again, it's menu option 7, then the downward silver onto the second screen, and this time I want option 2, which is Poisson PD. That's the probability distribution, so it's not working out a cumulative distribution, it's just working a point value. And again, I'm going to variable, and this time x is equal to 2, or x2, press the equals. My parameter lambda is 0.925, press the equals again, and out pops my answer, 0.1696410,977, 0.1696. Same thing. All right, so it's always important on these questions to work out what's changed.